My name's Fred Schott, and welcome to ES.Next. I cannot wait for this conference. A huge thank you to everyone watching right now, to our 12 amazing speakers. Thank you all for being a part of this and making this conference as exciting as I know it's going to be. My name's Fred Schott. I co-organized this conference with Drew, but I also work on a project called Pika, an open source future JavaScript project that you might have heard of. And I also work on a project called Snowpack, which is a future next-gen build tool for JavaScript. So very clearly out there, you can probably see the theme there and how we settled on this conference topic. But this is a really exciting time to be talking about the future of JavaScript. It's something I care about very much, obviously. And it's also something that I really have been working for the last couple of years on. And so what good keynote doesn't have a cool sort of one more thing reveal at the end? So stick around. We have something really cool to show off at the end of this in about a couple of minutes. And I think you're really going to love it. It's our newest project for what I've been working on with Pika, and it's probably our most exciting release ever. So just to get your expectations as high as possible, to come in just right at the line. No, we'll get to that in a second. But I first just wanted to talk a bit about ES.Next, right? The first question I got about ES.Next as a conference name, right, is what is that? No, like literally, what does that term mean? You might have seen it around. It's kind of this like colloquial, almost like informal, amorphous maybe term for just the future. What's coming next for JavaScript, which is kind of why you don't see it that much, because it changes in time, right? It's kind of hard to document it because it just always kind of means future JavaScript. Things that are coming down the pipeline that are expected soon, but aren't really ready for usage, right? They're not standardized yet. They're not a part of the language spec. JavaScript coming soon is kind of the way I'd frame it. So this seemed like a really fitting talk for the future of JavaScript, right? This was what's coming next for JavaScript. And some of the talks that we're going to see are zoomed really in, what's something coming now? And some are zoomed out, right? What does the future of the web over the next decade look like? Is a really interesting question to ask. This is a really interesting kind of what's next for JavaScript. And it's a really interesting time to be asking that question. 5 years ago, maybe you'd ask me what comes next for JavaScript. I probably would have just said, more React, more Babel, more Webpack. These are kind of been the staples of the last decade almost of how we build websites and how we think about them. And you might not use all of these, but this has certainly been the tool set that I've reached out to over the last decade and what I've recommended to people to get started with. This is certainly, there's a ton of innovation going on in different areas and within these projects themselves. But, if I could sum up the last 5 years, it's been, React, Babel, bundling, transforming. It's build tool heavy and really an exploration of what this more JavaScript centric web development meant. This has been great for JavaScript, but it's left, the staples, the pillars of the last decade have been pretty stable for the last 5 years. I don't think that's the case anymore. I think things are really changing kind of beneath our feet right now. There's been this almost like explosion in innovation, and some of that is stuff that's been building over the last couple of years. So to that point that the last 5 years haven't been innovation-less. Projects like Svelte and GraphQL are two really exciting projects that are really starting to hit the mainstream. There's different, what else? There's plenty of stuff. I had a whole little list here too. ES-Build is a very cool build tool that is bringing native speed to build tools. So it's using WebAssembly. I think it's written in Go or maybe Rust, and it's like, if you haven't used it, it is super fast and really, really powerful way to bundle your application. Still new though, right? Still a little bit more experimental, but you can see the chart, the path that they're charting there. Snowpack, the project that I work on, along with Rome and Vitae and these others, are taking a look at what does the dev environment look like when you build a web application. Going from that world of bundling towards something maybe new, something in the future. All of this is really hitting its stride over the last year, it's felt like. And I don't think I'm the only one who's recognized this. Sean actually had a great, Sean Wang had a great post on this a while back where he called this next decade the third age of JavaScript. And what that really is identifying is that, again, the ground is shifting under our feet a bit. There's actually a lot going on right now, some of it unrelated, but a lot of it actually tying together to create a new, I mean, he had it perfectly, age, a new kind of, or epoch, or era, a new type of web development. In the same way that React and Webpack and Babel have all kind of signified, been these pillars of a way of doing web development for a long time now. You can start to see, based on new technologies, new improvements in the network, Jamstack I think would be a great kind of example of how this is coming to pass. This new type of web development is becoming possible. So if there was ever a time to say what's next for JavaScript and for web development, it would certainly be at the start of a bigger change like this. Sean says the next decade will be defined by this, whatever it is, and I think that's a really interesting frame. And it's one that I'm obviously very excited to explore over the next week of this conference. Pika, I mentioned, is a project I worked on. This was how it was launched about a year and a half ago. Yes, that is the logo I went with, and no, I have no idea what I was thinking. I think at the time I thought I was being this hip designer, where maybe I learned like what this filter was in Photoshop. I don't know. The point is, this is, I am proud to say, the first thing I've ever built that has made someone physically ill. It hurts to look at, is not fun feedback to get, but I certainly feel like I earned it at least. So that was a bit of an achievement unlocked there. Pika was a project I started about a year and a half ago just to start to explore the space. Specifically something called ESM. So it was this idea that, and you can see here, I gave it a much nicer logo, don't worry. No one else I think has suffered from that logo in a while. Pika was created to start to explore this new space, and specifically something called ESM, which is, if you don't know it, ES module syntax. It's that import-export statement that you see in JavaScript today. A while ago, this was fairly rare, and then it got standardized in 2015, and then people started to write in it. And finally, we started to really use it as this sort of the target that we publish to or that we deploy websites to. This is really in the last couple of years come into its own as a technology. So all it is, it's a really simple feature at its core. It's importing and exporting. It's a native module syntax. This had never existed before, right? Essentially, userland, us as developers, we had to ship a module system to the browser, or if you're Node, you created CommonJS, which was that require function, if you've seen that. There have been, over the decades, a ton of different ways to load code in the browser. Going back to just like script tags nested and ordered in a specific way, to load scripts one at a time and like implicitly rely on each other. We've tried everything as a community. This is the first time that native module system has made its way to JavaScript. So any environment can implement this, whether that's a browser or Node or Deno, and anyone can use this as the module system. Not only is this a new syntax, right? It's a really clean way to import and export, but this actually changes what's possible for the web and for JavaScript. Having the ability of the browser to understand a file, not just as a script to run, but actually a whole dependency graph, right? What does this file rely on, and what does it share with the world? So ESM caught my eye really early, as not only is this a new syntax that we'll all be using, that's on its way as we speak into the browser, and today it's finally, I think 2018 was the last modern browser to ship it. So this is here by all accounts. You can use this in most production websites today without issue. what's so exciting, what makes this, I think, a really big part of why we see so much changing, why this third age of JavaScript is even here, is that this allows the browser to go out and load code kind of however it wants, right? So it can actually, in parallel, fetch all of your dependencies and go through the tree like this. So not only are we given this nice syntax, but we're also giving the browser a ton of more power and more control of how it loads your application. Going from the world of bundling, where the bundler decided how your application was loaded, and it essentially took that responsibility away from the browser because it didn't exist at the time, bundled your files together into these larger bundles and shipped into the browser. We're starting to move to a world where now the browser can control how it loads your application. It understands the module graph, the dependency graph. It understands these connections that are really high fidelity. And what can you build when you have that power? That was a really exciting question to me. So Pika was created to explore the space, and a bunch of different experiments have come out of that. Let's see, we had a CI/CD pipeline that let you literally like import a PR as ESM. It was a really wild concept. A code editor for building packages in this way, a package registry for hosting, every package is ESM. A package creator for NPM package authors, just all of the stuff in the space of bringing this technology to people and making it easier to work with was kind of our guiding principle for Pika. Snowpack was probably the first culmination of all those different experiments into something that we could kind of present to users in a really clean way. So Snowpack is a build tool. It's a dev tool really for building web applications. And it's fully powered by ESM, and it's a total shift in how you would architect a build tool. The easiest way to explain that is just to show it. This is Snowpack starting up in 7 milliseconds, and this is Create React App starting up in about 33 seconds and change. And the difference here, right, is it's still, the end result is the same. It's still an application running in the browser, hot module reload, TypeScript support, transpilation. Snowpack, you can attach whatever bundler you want. It's not making any sort of hard decisions about what the final product looks like and what you build with it, but it uses ESM. And what I mean by that is you write your application using ESM, and it totally leverages that to deliver an experience totally different from what we've had for the last 10 years, or really ever. What it does is because the browser can now understand the language that you're writing, Snowpack ships those files unbundled to the browser. So no longer is there a big startup cost, a lot of processing power. Snowpack just does less, which is how it gets so fast. Essentially, startup time is just starting a server, right? A node server, and Node's very quick at doing that. And so you start the server, and then it's immediately ready to accept requests. And then on each request of any file, of any user request, in local development, that will be what spins up a build of that one file. So individual files are built. Individual files are cached. If you never change a file, Snowpack's actually able to cache that file forever. So you will only have ever built that file once. Again, going from the world of bundling where you change a file and we now have to rewrite an entire bundle, that's a really heavy cost in development. And so Snowpack is this total departure from that world, using ESM to change the whole set of requirements for a build tool and what is possible in development. There's a lot more there. You should really check this out if you haven't seen it and you're a web developer. I can't tell you how shocking it was to go from Snowpack back to Create React App when I had to spin up an older application that I'd worked on. I forgot that that's the world. And maybe you haven't seen this, but I certainly have seen applications ranging from 15 to a full 60-second startup time, and then on each save you're rebuilding and rebundling. It just totally changes the way you do web development, and so I really, really recommend that. It's probably my favorite thing we've done up to this point. Pika's second most exciting project, and the one I want to spend the rest of the time just briefly touching on, is our CDN. So this was a CDN not too different from JS Deliver or Unpackage when we first launched it, but with the idea that it was purely focused on ESM packages. So we really restricted what it would allow. I think we only supported maybe 50,000 packages when we launched. that you could import by URL, loaded in the browser from any website. And again, because it was all ESM, we basically gave you a single unified interface for loading packages. So, right, you could actually run this import statement in the browser, and using an import map, or you could put a full URL in the React statement instead. But at its core, what this was doing was loading React, the package, from our CDN. So you didn't have to go and find the right file within React or put a script tag anywhere in your application. You could just give it the URL for React, cdn.pika.dev/react, and that was it. Your application would run using React loaded from our CDN. There was this really cool model where you could not just change how you build an application, but actually like get rid of build tooling entirely. Get rid of Webpack if you wanted. Great for small projects, prototyping. You could run these import statements anywhere on the web and they would just load React, and that was your site. Perflink is a really cool site that's built off of this. If you've seen that, it's a really pretty but very powerful benchmarking tool for JavaScript. I think it's perf.link. That is a really cool example of something that was built using Pika CDN to just save a bunch of time, save a bunch of effort, and just totally powered by an internet of packages connected to each other. So this has been probably our second most exciting thing. And again, we went from a world of supporting only 50,000 packages to today we support every package. So that was about a year and 1 month and 1 day ago we launched this. Today we support every NPM package. And since that launch date, we have served over 2 million packages to the internet across 2,000 plus unique domains. This is a really, really cool sense that we're onto something, right? Those are really exciting numbers to see. And they aren't really across any one spectrum right now. We've seen really fun kind of takes on applications like Perflink I mentioned. Nightcore is a really cool way to pitch shift audio to create these really cool remixes, again, all in the browser using our CDN. But also really important businesses have built on top of this as well. Very large tech companies or electronics companies have used our CDN. So this is a really, really cool model that we're really excited to keep developing and keep expanding on. And in case you haven't figured it out, I'll give away the big twist, which is that this is what we're announcing, is that 1 year and 1 month after this first launched, 1 year after development and all this beta testing, kicking the tires, bug fixing, feature development, we are finally ready to launch the CDN as its own service. This is Skypack. This is a way to load JavaScript from anywhere, and not just like a traditional CDN, but actually as a package delivery network. So if you've used Pika CDN, it's the same concept, but now evolved a bit. It works across every package. It works across every site. It is completely free to use. It's really, really exciting, and we hope this Skypack name gives it a chance to grow outside of the Pika kind of open source experiment and into a really powerful service that you can use in applications of any size. I'm so excited to show you guys this. I think the easiest way to show it, again, is just to show it. So the rest of this, there's no more slides. I'm just going to jump around a bit. You can see I have here just the website loaded up in a browser. So this is the new skypack.dev. You can still see everything about it, much more clearly presented than the old site. But this is really to capture what this does. You can take a look at this. This is a ESM import of a package called Canvas Confetti. And you can play around with running it right now in your browser. Powered by Skypack, this is loading code dynamically onto whatever site you're on. Your site or a prototype that you're working on. It can be a fun project like Canvas Confetti, or it could be something really important like React, Svelte, something you're building on top of to serve your users. Anything on NPM can be served from Skypack. And I want to show you in the console how you can use that. So you can load React, you can load React DOM, you can load Svelte. Right here, I'm just using that dynamic import. So this isn't something that I've written into a file. It's something that is essentially on demand, going out, fetching this code, and bringing it back so that I can now use it. For example, here as a module. This is really cool and really powerful, and you can build anything on top of this. You can see in the network panel those files coming in over the wire as they're loaded on demand. To give you an example of how this looks, let's open up React. I'll actually load it here with the dev console loaded. Right, so if you look here, this is the response that comes back. It's a really simple response, essentially resolving this lookup of the React package to a specific version. So React, right, that's a really, depending on when you make that request, it's always going to return you the latest version of React. You can certainly pin this to any version you want. Or sorry, 16.13.1. You can use semantic versioning, so you can kind of just say, give me the latest without any breaking changes. You'll see this lower, more specific import below hasn't changed. They all resolve to the same version of React. So here is where we're loading the actual resource itself. This is what's actually returning the JavaScript that you're going to load. And we'll pull this up separately. Or actually, the easiest way will just be to, again, put this into a import statement with the actual subvar. Debugging in action. Right, we need the version @ symbol to separate the package name from the semantic version. So you can see our failed request there, the correct one here. So because this response is containing its own exports from this URL, that is then telling the browser to go out and fetch React. And React here has a dependency on object assign, so that's going to go and fetch this object assign. So you can see from one URL, we get this really powerful, driven by the browser, version resolution and dependency resolution, where the browser is able to go out through your different dependencies and resolve a full tree that you can build on top of. Regardless of what your packages you're using, that's the browser doing that work. A few really, really cool things to highlight here. If we jump back here really quickly, you're giving this, and we'll just for simplicity, you're giving this URL the React package name. But here you can see we've added this dist data. Dist data is essentially how we optimize the response for your individual browser. So this is something that we do that no one else does, where the actual response is optimized to the browser that makes the request. So if you load your site powered by Skypack using the latest version of Chrome, you'll see this ES 2020. That's the latest version of the code that we can release. So it's modern, it's fast, it hasn't been transpiled too much, it doesn't include unnecessary polyfills. Modern browsers get modern, fast code, inhibited by heavy polyfills, heavy transpilation bloat. You get a really quick response in the browsers that can support them. Compare that to the traditional bundled application, and you're essentially having to decide for your entire application what browsers you want to support. And then when you make that choice, that ends up going out to every browser, whether it's a modern browser or an old one. You have to send out all of the polyfills and all of the transpilation that ends up slowing down that application for everyone, regardless of whether they need it or not. Wasted bytes for a lot of your modern users. So what we're able to do is for your dependencies, regardless of, you just say, I want to load React, but what we do behind the scenes is give you an optimized response for every browser. Only older browsers pay the cost of transpiling for older browsers. Modern browsers get modern code. This is probably one of my favorite features. And again, no one else offers this. So it's really, really, really cool feature. The other, talking more about optimizing and how we can optimize these responses to be faster than what you're building today. Caching is something that we take really, really seriously. So again, showing you what an import looks like of React. You can see here that the version of React that we load has this unique hash. It has its version. It has everything you need to give you back a URL that will not change. So not only can you rely on this reliably that it won't change, but you can also then cache it in the browser. You can see here that we say this is public, immutable, it won't change over time, and feel free to cache this for up to a year. That's us saying that this won't change over time and that the browser is able to then locally cache it in the browser, and it will never make this request again as long as it's in that cache. Again, going back to comparing this to what exists today, in a bundled application, you kind of have to make this decision of how you're going to handle caching, and neither choice that you're offered is really perfect in terms of what it can and can't support. You're either putting everything in hashed bundles, where when the bundle contents change, the hash changes, similar to this method we're doing here. But because it's a bundled application, you're mixing source code and dependency code. So the source files and the dependency files, they all change. Those bundles change whenever a file within it is changed. So you end up having to re-download code after a redeployment. Your users are never getting that fully cached up to a year story because every time you change code and redeploy, your users are re-downloading chunks of your site. The alternative is to request files without a hash and then let the server tell you whether they're accurate or not. So kind of that like edge caching. A lot of Vercel and Gatsby sites will do this, but the problem there is that then you're actually having to make that request to the server. Even if the server is just saying, you're still good, that's still cache friendly, that's still a request and response that needs to happen over the wire. So again, Skypack is really one of the first solutions to offer this full dependency caching, while still letting you build your source application using the hosting platform that you like, your current hosting favorite tools and favorite platforms, and choosing a caching strategy there that works for source code that changes often, and letting us own this really, really cache aggressive and performant caching strategy for your dependencies. The last thing I'll end on, which is probably one of my favorite features here, you might have seen this earlier, this pinned URL. This is optimized for production. So this is the production side of the lookup URL that you've been seeing so far. So looking up by React, right? That's a really powerful way to get back the latest version of React. But in production, you don't really want that, right? You kind of want to pin to a specific version when you deploy to production. You don't want changes over time. These pinned URLs are essentially offering you that plus a bunch of different performance optimizations. When you use a pinned URL in your application, so actually import from this pinned URL, the bad paste. The response looks the same, but there's a few key differences, and I'll show you that here when we import this. So for starters, this is pinned to a specific version, right? So this will not change. You can deploy using this URL, knowing that your application will act the same today as it does a year from now. That's a guarantee of the pinned URL. The code return doesn't change. What's cool about this is that it also does that same optimization for your browser. So it's a dynamic response, right? Two different browsers will get back the same answer, but we run it in a cloud worker. This is powered by a Cloudflare worker, which means it runs close to your location. So you can see this response going back still really lightning fast. It's running close to my location. It's not going back to any sort of data center. Really fast differential serving and a really fast response for the resource I'm requesting. What's also cool here, you'll notice here this deep imports perf optimization. One thing you might have noticed if you were looking for it was that in the lookup URL case, the case I was showing earlier, you would load the lookup URL, you'd load the resource. Okay, the resource has a dependency, you'd go and load that dependency. You end up with this waterfall of requests over time, right? They can really add up if it's a longer chain and slow down your application. What pin URLs do is that in that actual original response, we will resolve the entire waterfall that you might run into. So every dependency deep down the tree will be brought up to this first top level response. What this line is doing is essentially telling the browser in the first response, hey, by the way, you're going to need this later, so go ahead and load it now. Zooming in on this waterfall then, you can see we have only one step here of loading the pinned URL and then the response of all of those resources. So you never get deeper than one step in the waterfall chain before getting all of your responses loaded. We can do this with something a little more complex to kind of kick the tires on it, right? So let's do React Router. That has a bunch of resources. And we'll get our pinned URL here. We'll use that to run the next import. And you can see here, it had to, I think, start that request up a bit. But if we go here, you know, again, if you zoom into this waterfall story, you can see here, and is this close enough? I mean, it's so, the response of the resources is so fast. Everything happens in, oop, there we go, in parallel. Even though these are multiple dependencies that you're seeing loaded in a deeper tree, that first response includes all of those imports back for you. And yeah, we can run that again to see a much faster first response there, right? That's that kind of native, edge cached response there that we'd come to expect from this resource. So this is really powerful in production. You get that pinned, won't change in production story that no matter how your dependencies kind of change over time, if you use that pinned URL, the response will always be the same. You get that really close to the wire, close to your location, edge caching speed. And then lastly, you get that deep resolution of your dependency tree. So no matter what, you're only ever requesting one thing, one step on the waterfall chain, one thing, and you get back everything you need in that response. And because of HTTP2 and even more exciting HTTP3 coming soon, you get this really fast streaming response where the browser can actually support multiple requests in parallel. This isn't any sort of blocking that you need to worry about or any sort of limited, older browsers that can only support like 6 requests at a time. That was a long time ago. With HTTP2, those multiple requests all share a connection. And H3, they actually stream over the wire really efficiently. So this is all coming together to form this idea of what the future of the web can look like. And it's a really exciting time to be working on this. So please check this out. Give it a spin. Load your confetti as much as you'd like. It's a really, really exciting time to be playing around in the space. And we really hope that this serves as the first, it's day one of this story of what it means to build on top of a network of packages where every request can be cached aggressively for you. Performance is handled for you. We essentially get to be your performance team at scale. And yes, you still own your application, your source code, that is yours to deploy. But by pulling out the dependencies, we can optimize what ends up being 90% of most applications for you. And again, you get that same caching, that performance story for 90% of your application for free. So this is something we're really, really excited to keep building on and really excited to hear your feedback as we go. Something with confetti. Who doesn't love confetti? So that's Skypack. Please check it out at skypack.dev. Let us know what you think. Again, thank you to all of you for being here, being a part of this, supporting these great causes. Thank you to our speakers. And I will leave you there. Have a good one and enjoy the rest of the conference. Bye.